Πάμε τώρα να δούμε μερικές πράξεις μεταξύ των δομών. Λοιπόν, έχουμε πράξεις. I will switch to English because maybe we will have Erasmus students in the audience. So, let's see some operations. Now it's very simple. If we have t equals 1 and b equals 2, then of course we can very easily do a equals b plus d, and then the result will be 3. Of course we can do all the usual operations, arithmetic operations, multiplication, division. We can even do integer division. Let me demonstrate this. Okay, let's make a new R script here. So if I have a equals 1 and b equals 4, and let's make this 3 here, then b divided by 3, b divided by a will be 1.3. But if I want to make the Euclidean division or the integer division, I can do it like that. So this means that I make actually this operation that we learn in school, 4 divided by 3. Then we say that 3 in 4 is 1 time, 1 by 3, 3. And if I subtract this 3 by 4, it will be 1, and then if I finish here. So this is the result, and this is the remainder. Okay, so you see here that b divided by a is 1, and if I want to get the remainder, it will be b by a, it will be 1. So this one here is this one, whereas this one is this one here. Okay, I can make all the usual things. The power, for example, it will be a to the power of b. This will be 3 by 3 by 3 by 3 by 3. And b to the power of a, this could be 4 by 4 by 4, it's 64. SQRT is like that, and log with base 10 is like that, and log with base e is like that. There are many operations. There is no meaning to show all of them here, because we will see them during the lecture. Okay. Now, what if we have a vector? For example, I have the vector a equals 10, 100, 1000. Okay, and I have the vector b equals 2, 3, 2. Okay, I can do all these operations here. The important thing is to remember that when I do vector operations, then these are made element-wise. This means that if I do this, for example, then this 10 will be I will get the summation of this 10 and 2, then this 100 will be summed up with 3 and this 1000 with 2. And the result will be a new vector which will have the values 12, 103 and 1002. 12, 103 and 1002. Of course, I can do all the other operations. The important thing is to remember that these operations are made element-wise. For example, I can even do things like that. This will be 10 to the power of 2, this is 100. 100 to the power of 3, this will be 1 million. And 1000 to the power of 2, this will be 1 million again. Now I should mention here that this way to write numbers is called the scientific way. It means, let's see it here. So for example, 1.2 e to the 6, it means 1.2 multiplied by the 10 to the 6, which is 1,200,000. I can even have negative number here, so 1.2 e to the minus 6, this will be, sorry, here I should write 6. This should be 1.2 multiplied by the 10 to the minus 6, and this should be something like 1, 2, 3, 4, 5, 6. So this says that this one here should be in the 6th position. 1, 2, 3, 4, 5, 6. Okay. So here, for example, 10 to the 100 to the third is 1 million. Is 10,000 by 100 is 1 million. Okay. Now, so it's very easy when these two vectors have exactly the same size. What's happening when they don't have the same size? For example, if I have the following, let's say that B is like this. So I have to sum up these two vectors. Now R is doing something funny and clever, but can lead to mistakes. So it's better to know what exactly it's doing. What R is doing in this case is, so I'm going to do this operation, is it makes a cyclic operation. So let's write it here. I have this vector, 10, 100, 1000, and I have this vector, 2, 3, and I'm going to sum them up. Okay, so what I will do is that first it will make a new vector, of course. The size of the new vector will be as big as the largest one, so it will have 3 positions. The first value will be the summation of this and this. The first elements is 12. Then it goes here, 103. And then it sees that the small one actually has no other element, and the big one has one more element. So what it will do is that it will go to the beginning of the small one, and will assume again these 2 here, and it will write 1002. In this sense, it will produce a result, but it will produce a warning as well. And the warning will be that this vector has 3 elements, this has 2 elements, and the warning will be that the largest vector, these 3, the size of the largest vector, is not a multiple of the size of the small vector of these 2. Okay, let's do it. So, longer object length is not a multiple of shorter object length, but the result has been produced actually. Now, in this sense, if I would have one more value here, let's say this one, then it will sum up the 10 with 2, this would be 12, the 100 with the 3, this would be 103, the 1000 with the 2, this will be 1002, and the 1 with the 3, this will be 4. Okay. And now things become more interesting, because if you remember in the beginning we said that there are no scalars in R, everything is a vector. In this sense, this operation is the following. I have the vector B, which is 2, 3. And I'm going to do the operation B plus 1. So this 1 here is actually a vector, and let's say that this is this vector here. And this 2, this B here is this vector. So again it will make this summation. It will produce a vector of size 2. 2 plus 1, 3. Then this small one has finished, so it will go to the beginning again, but actually it will go to the only one value that it has. So this 3 will be summed up with this 1 again. 3 plus 1, 4. Effectively what it does is that when we do this operation here, it will add 1 to all the values of B. But behind the scenes, what it will do is that it will consider that this one is a vector of length 1, and it will apply this cyclical operation that the smaller vector will be recycled when it will finish. And of course, the length of this vector is 2, the length of this vector is 1, and of course 2 is a multiple of 1, so it will not produce any warning. So B plus 1 equals 3, 4 as we expect. Now this is very useful, and I think this is the reason that everything in R is made to be a vector, just for consistency. The same is true for matrices. So let's say that I have this matrix. So values from 1 to 10, number of rows equals to 2, and number of rows equals 2, and number of columns equals to 5. Since I put 2 here, I put 5 here because I have 10 values. So 2 multiplied by 5 is 10 values to fit them in a 2 by 5 construction. Okay. So if I could do A plus 1, very easily it will do exactly the same what we did with the vectors. It will add 1 to every element of this matrix. So this 1 will be 2, this 2 will be 3, this 3 will be 4, and so on. Again, we have here a smaller vector and a matrix, and we'll do exactly the thing that we said before. Now what will happen if I will do this thing? So I have a matrix here, and I want to add a vector to it. I have this matrix here, they're going to add this vector. So what R is doing in this case is that make the summation column-wise. So it will start with the first element of the matrix, and it will add the first element of the vector. Again, this will be a new matrix. Now the first element will be 2. 1 plus 1 equals 2. Then it will take the second element of the matrix, and the second element actually is the one on the first column. That's why it goes column wise, and it will go with the second element. So 6 plus 2 is 8. Then we'll go to the third element of the matrix, which is this one here, because it goes column wise. So it finished the first column, it will go to the second column, and then it will add it to the first element of this vector again because it just finished the operations. So 2 plus 1, 3. And then this 7 with this 2 here, this will be 9, and so on. So it's 2, 4, 4, 6. Let's see what's wrong here. Yeah, sorry, I wrote the matrix by mistake, erroneously. So the matrix is not the 1, 2, 3, 4, 5, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's do it again. So the matrix is actually this one, 1, 2, 3, 4, 5, 6, 7, and so on. So 1 plus 1 is 2, 2 plus 2 is 4, and then this finish, so it will go to the beginning and then it will go here again. 3 plus 1 is 4, 4 plus 2 is 6, then it will go again here. 5 plus 1 is 6, 6 plus 2 is 8, and so on. So it's 2, 4, 4, 6, 6, 8. 2, 4, 4, 6, 6, 8. I had just written wrongly the matrix. Okay. The same is true when, for example, I will do this operation. I have a matrix of length 10 and then I have a vector of length 10, and the summation will be exactly in the same order. So what I will get is that this element of the matrix 1 will be summed up with 1, 1 plus 1, 2. And then this 2 will be summed up with 2, 2 plus 2 equals 4, and then this 3 with a 3, so it will be 2, 4, 6, 8, 10, 12, and so on. Let's see what will happen if I have a bigger vector here. Error. The dimensions product 10 do not match the length of object 20. So I cannot add a longer vector than the number of the elements of the matrix. I should have less or equal number of elements to the matrix. Again, if the length is smaller, like this one, it will do the summation element-wise, and in the matrix will proceed on the columns. If the length of this vector if the size of the matrix, or if the number of elements of the matrix, which is 20, is not a multiple of the length of the vector, it will produce a warning, but actually it will do the operation. So here it will be 1 plus 1, 2, 2 plus 2, 4, 3 plus 3, 6, 4 plus 1, it will go to the beginning again, 5, and so on. In the last repetition, it will end to probably to 1. It will sum up the 10 that was here with the 1. It will not finish the vector, that's why it will produce this warning here. Okay. The same is true when we said that with vectors, with matrices, it's very important that we'll do this cyclical thing, this circular thing. When it will finish the smallest object, it will go to the beginning of the smallest object, and then it will continue the operations. When we sum up matrices, let's say I have this matrix, 24, and I have this B also, but goes from 21 to 30. A plus B will be a new matrix, element-wise the operation. So 1 plus 21, 22, 2 that was here plus 22, 24, and so on. What if the other matrix, the B matrix, is smaller? So let's say that it has 2 rows but just 2 columns. So this now will be 4 elements. It will be this matrix, let's see it also. 21, 22, 23, 24. What will this produce? Error, A plus B non-conformable arrays. It cannot do the operation with matrices because it cannot understand how to do the summation when the two matrices do not have the same size. However, when we sum up a vector with a matrix, or when we do the operations between two vectors, R has no problem because it will do this circular trick. Okay, so these are the important things that we should remember with matrices and vector operations.